Okay, so we're just going to continue our work into some quadratics here. So before we get too far into it, though, we got to start looking at a new kind of algebra that you may have not done before. So what I'm going to ask you to recall from grade 9 is just working with the distributive properties. So back in grade 9, a very typical problem you would have gotten is, you'd say you got a coefficient out here of -3 outside a bracket x plus 4. And whatever method you guys were taught last year, you would have done some sort of multiplication, distribute that -3 through the bracket, so you'd have -3 times x for -3x, and then -3 times 4 for -12. Okay, and that's what we call using the distributive property to expand and simplify expressions. And so we're going to do something very similar, just with slightly more complicated expressions, and we'll see why we're doing that as we do it. So a couple ways we're going to go about doing it. You can use the distributive properties, what you did back in grade 9, and we can also use things called arrays or algebra tiles. So I'll go through all the methods, and hopefully you can find a method that you prefer. So what we're going to have to remind ourselves of, if you've never seen algebra tiles before, the way they work. So we got, in this case, we got red and blue tiles. The big squares are x squared tiles. The rectangles are x tiles, and the small squares are ones. Reds are positive, blues are negative. So if we're going to look to expand something, we're going to be multiplying two expressions together. We're going to use those expressions as length and width, and we're going to find the area, which would be the result of multiplication. So I'll show you what I mean when we take a look at this first example here. So we're going to use algebra tiles to expand x plus 2 and x minus 3. What we're going to start with taking x plus 2. So in algebra tiles, our x is this one right here. So we have x, and I'm going to take a plus 2 and put it right here. Okay, so this over here, again, is just going to be x plus 2. Now, x minus 3 is going to go along the side down here, so take an x tile, and I take minus 3. Okay, and again, just indicate that there. So again, we're using x plus 2 and x minus 3 as our length and our width, and we're multiplying together, so we're going to try and multiply length and width to get the area of what's inside. So we're going to do this piece by piece. So over here we're going to have x times x. You multiply x next, we get x squared. So I'm going to take an x squared tile and put it into here. Over here in this section I have positive 2 times x. 2 times x is 2x. So I'll fill this in with two x tiles here. Down in this section, the bottom left, I have -3 times x, so that'll give me -3x. Okay, and last but not least, I have -3 times positive 2, so that'll give me a -6 down here. Okay, so we've done that multiplication now, and now we just got to see what our overall result is. So just to remind ourselves here, in the middle we have, let's change color here, so I'm going to have x squared. Here I have 2x, -3x, and -6. So all together, I have x squared, 2x minus 3x. Collecting your like terms here, we got some 0 pairs here. These two positive x's cancel out with 2 of these negative x's. I'm left with 1 negative x left over. And here I have -6. I'm left with x squared minus x minus 6. And now I've just expanded this and simplified it. And that's essentially what we're doing here. We're taking two binomials here, expanding them out, and seeing what they look like, and seeing what the answer is. Now, you might be wondering why we're going about doing this. Well, you've done a bit of exploration with quadratics, and you'll notice here that what we have for our final answer looks a lot like the standard form of a parabola. What you have on the left looks a lot like factored form. So this will be the algebra that we need to go from the factored form of quadratic to standard form. So we saw that different forms will tell us different pieces of information about the graph. So this is one of the ways you can start moving between these forms. Using algebra tiles is all well and good, but it can get a little bit tedious. If these numbers got bigger, then you'd have a lot more tiles. It'd be a little bit harder to work through. If you have fractions, that's hard to represent using tiles. So while tiles work, it's nice to find a sort of a more visual way that's not necessarily as cumbersome to use. So that's what we're going to do, what we call an array. So this down here is called an array, and I've made it a 2 by 2 array. So 2 rows, 2 columns, because our initial binomials here, x plus 2, x plus 3, they each have 2 terms. So the way we could do this instead, we could take the x plus 2, put it along the top, the x minus 3, put it down the side, and do exactly what we do with algebra tiles, except now we can just write out, just jump straight to the final algebraic answer. So x times x is x squared, 2 times x is 2x, negative 3 times x is negative 3x, and negative 3 times 2 is negative 6. So we're filling all the individual boxes of this array using multiplication. And again, to find our total area, that's everything that we have in here, we're just adding all this together. So our final answer is x squared plus 2x minus 3x minus 6, which of course I'm just going to simplify using my like terms, x squared minus x minus 6. So now I've used an array to simplify, get the answer, and I can do it much, much faster than using algebra tiles. Okay, so this sort of summarizes the whole idea behind using an array. So here you have a compound shape, it looks like a house. So if you want to find the total area, you'd find the area of the square, add to the area of the triangle. So again, with our problem right here, we had a length and our width, and our answer was the total area in between, and that total area was just adding up all the information from all the boxes. So here we added up x squared, 2x, minus 3x, and minus 6 to get our final answer. Okay. So this is the algebra tile method, and the array method. You could also have done, if you want to use the distributive property you saw back in grade 9, you could have done the exact same thing. Let's say we started with x plus 2 times x minus 3 again. So using the fact that, in grade 9 we only had a monomial here, a single term distributed through, we can do the exact same thing, distribute this entire first binomial into this bracket. So if I take the x plus 2 multiply into here, I have x, and that first term x gets multiplied by x plus 2. Okay, and then I'm going to have the minus 3, which also is getting multiplied by x plus 2. Okay, and then what I have now is a situation where I can do distributive property here and here, and I'm going to wind up with my exact same answer in the end here. So I'm going to go here, I'm going to get x squared plus 2x. Here I get minus 3x minus 6, and that's going to simplify to the exact same thing I got up here or down here. So 3 methods of doing the exact same problem, and you can choose whatever one you prefer. Okay, so let's just give you a couple to practice here and let you guys try these on your own. And so pause it for now and push play when you're ready to see the answers. So I personally chose to use arrays for this one. So again, I took my first binomial here, we used x plus 5 along the top, and then I used minus 2x minus 3 along the side. Now, I could have switched the order. I could have had x plus 5 down the side and negative 2x minus 3 along the top. It doesn't matter as long as you're being consistent. And then you just, again, fill in each one of these boxes through multiplication to get each of these. And then what do you have to watch out for? You got to look for all your like terms. So here I have, if you look in the middle, I have a minus 10x and a minus 3x. So I had to simplify those, add those together to get minus 13x. That's how I got that middle term there. Next one over here, same idea. Again, you have a binomial on the top and a binomial on the side. Fill in with multiplication. You just got to be a little bit careful. All the ones we've done up to here, you've always had the x squared in the top left and the constant in the bottom right. This, because of the order of the terms inside each bracket, it sort of changed things around. So now your x squared term is up here, your constant's in the bottom left. And again, as long as you're being careful with your like terms, you're not going to make a mistake, but you just got to make sure you take the time to avoid making little careless errors. So here are my like terms. I have a 9x here and a negative 28x here. So I simplify those, add them together to get the minus 19x. One thing you might want to do for this one, if you prefer having all the x squared terms in the top left and your constants in the bottom right, you could have actually rewritten this first binomial pair as negative 4x minus 3, and then use that to set up the array that way. So it's just another way of going about it to might make it look a little bit easier for you. Okay, so this whole idea works. I mean, most of what we're going to be doing in grade 10 is doing binomial times binomial, but the nice thing about using arrays is that it's very easy to expand this out to larger polynomials as well. So here's something that's actually a lot more complicated to look at. It's a 3-term polynomial multiplied by a 4-term polynomial, but it's the exact same concept, so we're just going to have a bigger array. So here I'm going to have 3 terms, so I'm going to have 3 rows for it, 3x squared minus 5x plus 2, and here for this 4-term polynomial I'm going to have 4 columns. So again, just a larger array, but the idea is still the same. So If I want to fill in these boxes, again, use multiplication. So for this top left, I have 4x cubed times 3x squared. 4 times 3 is 12. X cubed times x squared. Remember from grade 9 your exponent laws, you're going to actually add the exponents. That's going to be 12x to the 5. Okay, so I want you to take a minute, finish this array, do all the multiplication, try and collect all your like terms, and see what we can get for a final answer. Okay, so that's what my array looked like when everything was multiplied out. Let's just do a quick check with what you did yourself. Just check for any errors. And just from here, you just got to collect your like terms. There's more like terms to collect here. There's 2x to the 4th terms. There's 3x cubed terms, 3x squared terms, and 2x terms to simplify. So there's a lot going on here. So just watch your addition and subtraction, and you should wind up with this as a final answer here. 12x to the 5th minus 23x to the 4th plus 31x to the power 3 minus 53x squared plus 47x minus 14. So again, a pretty ugly answer, but you know, same concept as what we were doing before with a smaller multiplication. Okay, now this was this question done using arrays. In theory, we could have done the exact same thing using distributive property. So what we'd be doing is we'd be taking, in theory, this first bracket and distributing it to every single term in the second bracket. Okay, so you'd have 4x cubed, sorry, that's a bad 3, 4x cubed, all multiplied by the 3x squared minus 5x plus 2. And then you'd have minus x squared times that exact same bracket, and then plus 6x, and you get the idea. So it just distributes through, and you can see that the algebra, it gets kind of messy, but you'll get to the right answer. So if you like using arrays, you'll never have to do it this way, but just keep in mind that this is a way. If you want to use distributive property way you learned in grade 9, this would be how it would work with these longer polynomials. So if you're really curious, you can try doing this exact same problem and doing this method and see that you get to the same answer. But I'll leave that for you to practice, and let's just look at some other examples here. Okay, so I'm going to give you one here to try. So as with all the other questions in this lesson, do try them first, and when you're ready to see the answer, we'll go through it together. Okay, so a couple things I want to remind us of before we take this up is we got 3 things multiplied. We got the 2, the 3x plus 1, the 4x minus 5. So think about when you have multiple things multiplied together. So let's just say I had 3 times 7 times 4. Okay, so I could just do this all consecutive. I could do 3 times 7 to get 21, 21 times 4 to give me 84. Or if I wanted to, I could do the 7 times 4 first, then multiply by 3. Or I could do the 3 times 4 first, and then multiply by 7. Either way, I'm going to get to the same answer of 84. It's just I'm changing up the order. So it's all multiplication. The order in which you do it doesn't really matter. So you get a choice here. You can actually start with 2 multiplied into one of these 2 brackets, and then expand from there. You could expand these first and then multiply by 2. It's really up to you. The only thing you have to watch out for is if you decide to multiply the 2 in, remember that there's no addition subtraction, there's no distributive property. In this case up here, with 3 times 7 times 4, you wouldn't go 3 times 7 and 3 times 4, so you'd be multiplying by 3 twice. Right? So if you multiply by 2 first, it only goes into one of the 2 brackets, not both. My suggestion to make your life a little bit easier, in my opinion, is to actually start with the harder part right here, the 3x plus 1, 4x minus 5, and to use an array to expand that out. So if I set up my array that way, I can fill in the boxes using multiplication. So I wind up with 12x squared, 4x minus 15x gives me minus 11x minus 5. And I've taken care of that tricky part now, and now all I need to do is take care of this 2, and then I think back to grade 9, oh yeah, I just distributed it in. So 2 times 12x squared, 2 times minus 11x, 2 times minus 5. So that should give me an answer of 24x squared minus 22x minus 10. Okay, we're going to continue this in part 2 of the lesson, so we'll see you over there. Thanks.